In this demo, I'm going to show you how to add SQLite in the browser for a Blazor WebAssembly app. You may have seen this demo in .NET Conf, but at the time, the tooling required building a special build of SQLite, including a native file reference. Now, everything can be done directly from Visual Studio, and I'm going to show you that experience. I've got my GitHub repo pulled down for the MVP Summit task list. This time I'm using the WebAssembly as a startup project. It uses a shared Razor component library. So this is shared between the Blazor server version that's in the connected services demo. And here we'll just run this to show you what the default experience looks like. And I can add tasks. This is Blazor Wasm. It's entirely in the browser. C# runs everywhere. I'll mark this complete. Now, if I click around, you'll see that stays, but the instant I refresh my page, it's gone because that was in memory. So we want to do something about that. The first step we're going to take is add some dependencies. And I'm going to add two. I'm going to install Entity Framework Core SQLite, and I'm going to use the core package. The SQLite contains everything you need. The SQLite core leaves out the actual SQLite implementation, which is what I want because I'm going to pick my own. So we'll install that, and then I'm going to look for something called SQLite PCL Raw, and they have these bundles that have everything you need. We're looking for this SQLite 3. Thanks to Eric Sink for building a version of this that understands Blazor WebAssembly. All I have to do is install this, and it will automatically get picked up by our project. Let's make a few changes here. When we're setting this up, we need to make this a DB Summit task service. Just like before, we need to add our DB context factory. So that's our Summit task context. And I'm going to use SQLite. This is just like I would do on a server application. And I'm giving it a data source name, to-dos SQLite 3. So that's our setup. And then I've got a special extension method that I'm going to use for a special factory, and I'll explain why in a second. So let's go ahead and do builder services add synchronizing data factory. And let's run this and see what happens. So we've now swapped out to use a data context. This is SQLite, and if you notice in the build, it's building with Mscripton, which is the Wasm compiler. So it's already recognized that there's elements that require Mscripton, and it's including them in the project. I don't have to add native file references or do anything custom. So we'll pop into our to-do app, and then I have 1, 2, 3. Now I'm using SQLite with EF Core. Now there is a challenge because by default, this is still an in-memory implementation. So if I do this, it's completely wiped out. So let me go make one small change in my synchronizing data context factory. And I'm going to uncomment these lines of code, which requires pulling in a reference. So what I'm doing here is when I deliver the context, I'm tapping into Save Changes. And in Save Changes, I'm making a backup of the file. So once you save your changes, I'm copying it to another file. This happens very quickly, but this gives us something to do in the background, which I'm going to show you first, and then we'll take a look at the code. So now notice that I had tasks actually already come back. This is a new task. We'll add that. I'm going to stop it. I'm going to rerun it. And you can see it's persisted. So how did we do that? It's actually very simple. In this custom data factory, before I pass back the version of the context here, I check for these pending tasks, which are queued up here, calling some custom JavaScript. Now, this is JavaScript code, but it's code that you can copy and use like you want. What I'm doing is I'm using the built-in browser caching, and I'm pretending like there's a URL with the database in it. And I'm basically using the virtual file system that's in memory and using that to restore the file from the cache or in the case of updates, write it to a cache. So this is emulating a response that contains the database as a blob. It's not very many lines of code, but by doing it this way, we have some interesting possibilities. In Steve Sanderson's video, he showed IndexedDB, which is a very valid way to do this. The reason why I like the cache is because of this. I can go into my cache storage. Here's my MVP Summit cache, and I can see what's stored in the cache here. Now there's some very interesting things we can do. There's a reason why I chose a blob specifically. I'm going to go back into my code and I'm going to change this to response equals await response blob. And I stored it as a blob for a good reason. Now this second one is going to fail, but I'm showing this so that you can see how to troubleshoot this. So this has an unhandled error because it choked on the code we added, but I'm going to put a breakpoint right here and refresh it so I can show you why I did that. So now in the console, we've got this result, which is a blob. The browser has a built-in capability called create object URL that allows me to pass it a blob, and it'll generate a link if I give it the right resource name. So with this link, I can click on this and it's downloaded a file. This is the actual database that I can then pull open into a SQLite browser and inspect it. So it gives me a little bit of flexibility in that way. And that is what it takes to add a persisted version of SQLite in the browser. Now keep in mind, users can easily wipe their cache, so this isn't guaranteed to be permanent. And don't store sensitive data. You saw how easy it was for me to get access to the database. Your users can do that too.